In this video, I'm going to quickly review some of the Module 2 concepts that we've gone over. So let's get started. First thing we talked about was solving systems graphically, and that is by finding the point of intersection of these two lines. So I'm going to graph this line real quick by going up one and putting a dot, and then from that dot I'm going to use the fact that the slope is 2 and go up 2 over 1. And I could keep doing that, up 2 over 1, up 2 over 1, and then I could draw my line. Now for the second line, it is not in y equals mx plus b form, so I'm going to have to solve for y first to make this a little easier to graph. So let's solve for y. First, I'm going to subtract 3x on both sides, and that moves the x over to the other side, and we see that now it becomes negative 3x on the right side. And now I'm going to divide by -2 on both sides. And now we're ready to graph the blue line. We're going to go up 3 and put a dot, and then from there we're going to go up 3 over 2, up 3 over 2, and we actually hit our red line right there, and that would be the answer. We would write the answer as a point. It is this point right here, and it looks like that's at 4, 9. 4, 9. Let's now move on to the next problem. Instead of graphing, we can also use algebraic methods, including the substitution method. This is where you take the fact that y is the same thing as 2x plus 1, and you plug it into the second one inside a parenthesis often. So in this case, I'm going to put the 2x plus 1 inside the parenthesis. So that leaves all the other stuff on the outside here. So we have 3x minus 2 equals -6. And now we do the distributive property and then combine the like terms. So we get -x minus 2 equals -6. If we add 2 on both sides, we get -x equals -4. In other words, x equals 4. So the point of intersection of our two lines, we didn't even graph them, but it's at 4 comma something. Now to get the other half of the answer, what you do is you come back up here to this equation, and you're going to plug your 4 in right there for x. So let's go ahead and plug that in. 2 times 4 plus 1, and that equals 9. So the answer is 4 comma 9. And if you recall from the previous screen, that was the exact answer that we got through graphical methods, 4 comma 9. All right, let's move on to the elimination method. To solve a problem with the elimination method, we are going to literally add the two equations together in hopes that something eliminates. Now I picked this problem on purpose because nothing eliminates right now. So we are actually going to, this is one of the harder ones where we're going to have to do a double transformation. We're going to have to multiply the first and the second by different numbers and keep ourselves organized. For example, I could ask myself what the first multiple of 5 and 3 is, and it would be 15. So I could change this to 15x and -15x and do all the calculations, or I could do 10 and -10. I think I'm going to do 10y and -10y here and turn those into that, so the y's will eliminate. So I went ahead and write the -10 and the +10 that I'm going to turn these into. Then I asked myself, how do I do that? Well, with the red one, the first one, I'm going to have to multiply by -5. However, for the second one, a -2 will do the trick to get that to +10. Now I have to multiply everything else in the first one by 5 and everything else in the second one by -2. So I'm going to go ahead and do that now. And now we're all set for the y's to eliminate. So we're going to add these two equations and see what happens. Let's go ahead and do that. Draw our equal sign and go ahead and start adding. We get 19x equals 19. Well, that means x is 1 when you divide both sides by 19. Now, in order to get the other half, of course, we come back up top once again, and we're going to plug 1 into one of these equations. I usually pick the one that has the smaller numbers. So I'm going to plug 1 in right there. So it's going to be 5 times 1, that's 5, minus 2y is 9. I'm going to minus 5 on both sides, and I get -2y is 4, which means y is -2 when you divide both sides by -2. When you divide both sides by -2. So the point of intersection of these two lines solved using the elimination method is 1 comma negative 2. All right, let's see what's up next. Oh, these are always everyone's favorites, these word problems. Now we're going to use a system to solve this. And so let's set up our little brackets. And this is one of those coin problems where in this particular problem, if you read it carefully, we have quarters and nickels, and we have a total of 40 coins total. Then you ask yourself, how do you count money? What is the value of it all? 25 times the number of quarters plus 5 times the number of nickels will give you 880 cents total. Now we're going to go ahead and solve this system. I'm going to multiply the first one by -5. That way the nickels will eliminate. So I will have -5q, -5n equals -200. I add these up, I get 20q is equal to 680. And I divide both sides by 20, and I get 34 quarters total. Now, since we know we have 34 quarters and a total of 40 coins in the pocket, we know it must be 6 nickels after that. So 6 nickels, 34 quarters would be our answers. We don't write this as a point because we are answering a word problem here. All right, let's move on. Okay, I wanted to be sure to go through one of these 3x3 systems. I know these can be lengthy. However, this one does come out just fine. And I've set it up so that if you look closely, the y's are in great shape for eliminating. Now, we need to use all of our ingredients at some point. So I'm going to combine the first and the second, and then maybe the second and the third at some point. And that way the y's will eliminate here and the y's will eliminate here, and I'm going to have an xz equation, actually 2 of them. So let me go ahead and add the first 2 together. I'm going to add these 2 together. And you see I've added them together and the y's eliminated. And now I'm going to add the second 2 together, these guys right here, and I'm going to write it underneath. So I've managed to use all 3 equations, and I got 2, I eliminated the y in both situations, so that now I have 2 xz equations. And I can set up elimination here. And I'm going to need to double this equation. I'm not sure why I put that horizontal line there, so I'm doubling the second equation. And hopefully you see why I'm doubling it, because now, take a look at this. Let me grab the highlighter here. You see that those add up to 0. So I'm going to go ahead and add the equations together now after my transformation of doubling the second equation. And I get 11x equals 11. Well, this is looking great. X equals 1 then. X equals 1. So we could come up here and we could write 1 comma. Now, we can't get y yet. We can get z, however. We come back to one of these equations and we plug our x in there. 3 times 1 minus 2z is -3. Minus 3 on both sides. You see -2z is -6, so z equals 3. So I'm going to go ahead and plug that in up here in the upper corner. Now that I have x and I have z, I'm going to go back to the original equations, whichever one is your favorite. I'm going to use this middle one. 1 minus y minus +3 is -4. Now I combine the like terms here. This is -2 minus y is -4. Add 2 on both sides and I get -y equals -2. So that means y is 2. Kind of ran out of room here, but y is 2. So I'm going to squeeze that in. So there you go. The answer is 1, 2, 3. Couldn't have been any easier, right? Okay, let's move on. The last topic we talked about in Module 2 was the graphing of inequalities, in fact, systems of them. And you've done some activities online to practice this, but let's go ahead and do these together. So we're going to first graph the boundary line. This one's going to be a solid line because it has the equal, and this is going to be a dotted. I wanted to be sure to have one of each. So let's go ahead and graph this boundary line y equals 3x plus 1, and I'm going to do that in red. So I've graphed the line y equals 3x plus 1. Now we have to decide which side to shade. Now you could do the 0, 0 test, or the simple thing here is since y is all by itself and y is small, you go where the y values are small and you shade that side, which means down. A less than symbol means shade down. So let's go ahead and do that. And finally, for the second equation, I'm going to go ahead and minus 2x on both sides because I would much rather have y equals mx plus b graphing. So now I can go down 1, put a dot, and then go down to the right 1. Remember, always go right if you want to be right. Down 2 over 1, or up to the left if we're backtracking on the line. Up to the left, up to the left, and we can then draw our line. And I made that dotted because it does not have the equal sign. It's y is greater than and only greater than. Now where is y greater than? Way up here. So we're going to shade on the top. So there's the top of the blue one. So then the question is where is the overlap? Well, the overlap is over here. So this would be the solution region. So then I could ask you, is 4, 2, is that a solution? And all you have to do is find it on the graph here. 4, 2. Is that in the green area? It sure is, so it's one of the solutions. All right, this wraps up the review for the test. So now you can go in and work on the assignment for the review and finish this up. Good luck. Hope this helped.